Good afternoon and welcome to the world of space research. My name is Zsuzsanna Benyó and the title of my PhD thesis is Human Adaptation to Spaceflight. It's no more rocket science that prevents us from going to Mars, but it's unfortunately the lack of adequate countermeasures to mitigate spaceflight-induced human health risks. I am a dietitian, graduated here at Semmelweis University, but just recently I graduated also at Unispace, which is a multidisciplinary space degree, where we studied also space healthcare and space economy. I can just highly recommend it to you. Semmelweis is also involved in the program. I didn't want to switch because I wanted to say thank you for my supervisors who are in charge of the Hungarian human spaceflight program, and we share the joint vision to achieve healthy longevity not only here on Earth but also in space. And that's why we are working on and aiming to establish even Hungarian TRISH, Translational Research Institute for Space Health. We have two specific goals, but I will go into details about this in the following slides. First, we prepared a systematic review and meta-analysis with the title, The Effect of Bisphosphonates in the Prevention of Bone Loss During Spaceflight and Microgravity Models. But why exactly this topic? Because if you, as a researcher, go to space, then you unfortunately experience 1 to 2% bone loss per month, which is 12 or 11 times more than in case of an older woman or a man in osteoporosis, because they use that amount of bone only within a year. So we wanted to examine, because I also work with the pharma department within Semmelweis University, whether bisphosphonates, which is an anti-disruptive drug and successful here on Earth, whether it would be good in terms of preventing bone loss in space or in microgravity models. So our aim was to investigate whether bisphosphonates can prevent bone loss in space. Our clinical question was, obviously, can bisphosphonates effectively mitigate bone loss under spaceflight or microgravity models? We used the PICO frameworks, so we examined studies or included studies where humans were either in space or in so-called bed rest studies. This means that they were lying in bed with head down tilt, imitating microgravity. So that's why it's used even by space agency as an analog model. And in every case, the intervention was bisphosphonates and the comparator was no bisphosphonates, and we were looking for outcome parameters related to bone loss. We had almost 17,000 hits. But after a careful selection, we identified 16 articles to be eligible. This is one of the key results, that we identified bone mineral density, lumbar spine, and here it's a very complex forest plot because you can see a column. It's called BIS group. It stands for bisphosphonates group. Here you can see the mean of change in case of bisphosphonate group. So compared to the baseline level, how many percentage the mean was changed when they took bisphosphonates, while there was a control group, and we managed to pull together the results, and since it was measured BMD, in this case in percentage change, we managed to identify mean difference in percentage change, and it amounted to 3.91, which is both clinically but also statistically a very considerable, significant result. We had similar results and concept in case of BMD femoral neck. Again, it reached more than 3%, a mean difference change, and it was again in favor, clearly in favor of bisphosphonates compared to control. in case of, because we work with 3 categories of outcomes. So the first one was BMD. The second one was bone turnover markers, including bone resorption and bone formation markers. And NTX was identified as one of the key bone resorption markers. And again, if you look at the results, again, it was in favor, I mean, the results was in favor of bisphosphonates, and again, even statistically at a significant level. We managed to pull together results also related to the bone formation marker, bone-specific alkaline phosphatase. And though it was in favor of bisphosphonates, as you can see, so it decreased. Since it crossed 0, it's statistically not significant result. In terms of hormone, parathyroid hormone is a key indicator related to bone health. And here, the result amounted to more than 4, which is, again, in favor of bisphosphonates, but again, statistically, it's not a significant result. Related to the limitations, if I may start with that, we gathered studies where there were always 2-arm studies. And after we collected them, because we followed our PICO, we realized that it would be nice to see also what happened purely without bisphosphonates. So we created even single-arm studies, which is in the supplement, related to all the outcome parameters, because in some cases, as you could see, it was not fully clear from the plot whether that specific outcome decreased or increased. So we have also this as in the supplement. But in terms of strengths, interestingly enough, it's the first systematic review and meta-analysis on this topic. And a high number of bone metabolism-related outcome parameters could be pulled together. And it's also great that we had RCTs when we talk about space research, because usually they are non-RCTs. In terms of further limitations, the number of subjects was obviously limited because we are talking about space. And sometimes the reporting about dietary supplementation was not fully clear from the studies or not consistent. So as a conclusion and the implication and the summary, bone mineral density clearly increased, while the bone resorption marker decreased, which means that bisphosphonates alleviated bone mineral density loss in space and in microgravity models. What this means as an implication, so far, there are no protocols by the space agencies using bisphosphonates. So we should really encourage further research related to this topic, so how to mitigate bone loss in space. But at the same time, we would also highlight that the research must be more standardized and safety must be investigated. And we have submitted the article to Nature Communications. The second study is also related to space. We want to investigate how spaceflight or microgravity influences body composition. Because again, for example, if you go to space, you lose even 20% of your muscle mass, even within a couple of weeks, not to mention long-term space flight. And with this, we would like to have a better knowledge about the potential risk of malnutrition, which is, again, an increased risk related to space flight. But it's also a risk related to bed rest, so when you are immobilized. So here the clinical question is, how do spaceflight or microgravity models affect body composition at different time points? And we are using a PEO model. In terms of additional activities, I'm a great advocate for space research. So I started this 5 years ago. So even before the university, I attended several conferences, won competitions, and I would be happy if you would join me in this journey. And this is the summary where we are, though we are also planning some practical, not only theoretical studies going forward. And I would like to say thank you to you with one of my favorite quotes, which is very much relevant to space, because space research is difficult, but it's also encouraging. So we choose to go to the moon, not because it's easy, but because it's hard.
My question is, how should I imagine this bed rest model? If I go to this RCT, what should you say to me to lie such amount of day to not to do something? There are specific departments, for example, in France. There is a hospital called MEDES. It's part of the European Space Agency's research facilities, and they are regularly recruiting people. And it's the same in the US. So they are recruiting people who are open to just lay in bed, and they cannot really stand up or even sit. In some cases, they are allowed to do exercises, but just while you are laying in bed. But again, since in some cases it's allowed and in some cases it's not, again, it's very difficult when you are doing a meta-analysis to really have, comparable data. In the US, for sure, they always have very strict criteria because they would like to have a similar group of people like astronauts. So they use usually the military type of requirement when they are selecting people for bed rest studies, so that they can really use that also for space research purposes. And in Europe, besides France, as far as I know, there is a facility in Slovenia for bed rest studies. How many days?
It can be even for a couple of months. For example, in these studies, it was for 3 months, usually. There are different models, animal models as well. For example, I'm a quarter with Amir related to space pharma. And there, for example, they are working with analog models with animals, and they have tail-suspended rats, for example, as an analog to microgravity or an analog to bed rest. But besides that, if we are talking about other fields of health, what is also very important that space agencies organize, and not only space agencies, but also university space analog missions. It means that space scientists are in a confined environment under extreme conditions, for example, in a desert or in a submarine. And they are imitating everything if they were already in space. Obviously, in our case, we couldn't use those analog missions because for this very specific topic, bone loss, they were not relevant because we really had to imitate even microgravity.
If I know correctly, that astronauts at the ISS are required to do like 2 hours of exercise or resistance training each day. Is there any data comparing bisphosphonates to exercise and resistance training?
Thank you so much for the question. Yeah, we always took a very special attention to the criteria that we are comparing always groups if they used exercises, even if we are talking about bed rest. We were comparing them with those bisphosphonates group which were also doing exercises. But coming back to your question, for the time being, there is a very strict protocol related to exercise. It's correct, but according to the findings, it's still not enough. And there is also an additional protocol, which is about dietary supplementation, and then according to the space agencies, astronauts should take vitamin D, also related to mitigating bone loss. They, according to the protocol, they take 800 international units per day. And then that's also a supporting factor.
So is the training not enough?
Not enough. Definitely not. So these results that I showed, this 1 to 2% bone mineral density loss per month is with exercise.
Oh, that's crazy. This is
that's
huge.
With.
Yes.
I would like to ask, how do they measure like bone density outside in space, or can they measure the weight somehow? So can we weight?
Two questions. Then
Yes.
first, maybe about the weight. Obviously, in space, you cannot use the usual scale. So that's a very good question. Maybe you have seen even the photo. That's why you came to this idea. So what they do, they use the so-called Newton's second law, which means that you can measure an object and a person's mass, so not weight, but mass, with this law, which says that force equals mass multiplied with acceleration. So there are two different methods, the US and the Russian, and they are different, and they are using both on ISS in the different modules. The US is with the lady. They are using a device where they have an oscillation and it's moving back and forth, and this is how they measure mass. The Russian is similar, but in a different direction. And this is the special device they use. And from that mass, they can make calculations for the weight. And this is how they can compare how the body composition changed in terms of mass. In terms of bone mineral density, that's also a very good question because they do not have a DEXA on ISS. It would be too big, and also because of radiation, they cannot take devices like this. So, for example, the Russians have a device where they use ultrasound. But again, it's difficult to compare the results. So in these studies, they always compared before and after use.
So of course, we know also from menopausal studies that bisphosphonates are very effective against bone loss. But there are some issues. I'm pretty sure you're aware. You know who are the specialists who hate these drugs? Yeah, the dental surgeons, because it simply destroys the structure and the quality of the bone, so you will never be able to reconstruct anything, to put any how to say, how did the dentist call them?
It's
the implants. You cannot use the implants or something like this.
Yeah, because it might cause jaw necrosis.
But besides that, as I knew, also the nephrologists are not very happy with bisphosphonates. So do they use bisphosphonates, or it's just an idea?
It's not in the protocol. So they are using this only for the time being for research purposes. But space research is special, especially if we talk about long-term space missions. For example, going to the moon, living there in habitats, because then the decision makers have to make a decision and draw a balance what to do, which one is worse, let's put it this way, risk of the one that you mentioned or losing your bones.
But there were astronauts who spent, let's say, a year in the Soviet era. They spent months in the space. So they lost half of their bone mineral density then, or
according to the studies, yes, it's that serious. And the bone is really an issue. It's not like muscle, because with muscle loss, you can regain your muscles. Yep. More easily, but in terms of bone, it's really a serious issue. And when we are talking about internationally having missions to Mars, having habitats, constant habitats because of space mining on Moon and on asteroids, then it's getting a more and more important problem to solve. Obviously, they are looking at different possibilities how to solve these issues. This is one direction, pharma.
Okay.
There are also directions related to nutrition and. Yeah.
I was wondering, you know, as a nephrologist, it is so far from me, the space research. However, I have a question which is very important to me to understand the whole stuff what we are talking about, because, for example, in high altitude, the process what's happening at a high altitude sickness is quite similar to COPD. But at the same time, it's reversible. So my question would be that if this bone mass, bone density loss or bone density decrease or reduce of bone density is reversible or not, and if it results in the same alteration of vitamin D and parathormone axis. That's a very important question because, for example, in CKD, it's a permanent change. I mean, what's happening during the worsening of the kidney function. But after kidney transplantation, it's like, it seems to be reversible most of the cases, most of the time. So my first question would be if it is reversible or not, the bone density loss, and how it, how it influences the, how does it influence the vitamin D metabolism?
Yeah, it's an excellent question, and kidney and nephrology has a lot to do actually with even with this topic. I will tell you a little bit about that one as well. In terms of reversibility, we didn't conduct a study focusing on that, what the figures show in this regard, but there are studies, they are included partly also here, where we could see that there were measurements afterwards, even after 1 year. But we didn't have enough data to pull together those data, whether they were reversible or not. So that's why it's also important to have more studies, even if it's bed rest. Yeah, more time, yeah, and follow up definitely. And in terms of a kidney, it would be also interesting to make a study how this topic is connected to the risk of renal stones in space, because it might have a connection to that. But again, there were not enough studies related to that for the time being. But it's a red flag at NASA, that for sure.
Thanks for the very enjoyable presentation, and you gave a lot of food for thought, that's for sure. My question would be regarding the vitamin D that you elaborated on already. Some of the studies go back way to 2003, and at that time the normal value of vitamin D supplementation was totally different than nowadays, and it's different according what kind of race you want to supplement vitamin D as well. So what do you think? The level of supplementation, you said that you don't have data in every case regarding this. Can it influence the results regarding the bisphosphonate study?
Yes.
And how can it influence?
Yes, yes. The current guideline is 800 international units in terms of vitamin D. Actually, vitamin D is the only vitamin which is supplemented for astronauts, interestingly enough. And even to, just to that level. And sorry, what was the other question?
So the amount of vitamin D supplementation, can it influence the results regarding that?
Yes.
Because this has changed during the years. It was much less in 2003 that was a prescription, or sometimes it was even higher. So it was totally different each year.
Actually, we took into account when we analyzed the data, and that's why, for example, I didn't show you, it's only in the supplement what we found related to calcium levels and vitamin D levels. So we have forest plots also related, but because it was not fully transparent, we decided to include these data only in the supplementary part.
Mm-hmm. And my other question would be, just because I'm curious, is that the bowel movement and bowel absorption is totally different in space than here. So in what kind of form would you supplement bisphosphonate if you really want to be sure for the study? So it's not easy.
Some of the studies use intravenous bisphosphonates. Some of them use pills. The majority of them use pills.
Yeah, that's what I was really curious about.
There were some cases, in two occasions, where there were side effects as well, and one of them had to even stop taking bisphosphonates.
Mm-hmm. Thank you.
I just had the same curiosity if you can give it intravenously in space, and also about the pill esophagitis is not the major concern, but it can happen. So that was my question.
And they started in almost all of the cases the treatment with bisphosphonates 3 weeks before the space flight or before the bed rest study. It was very similar.
I have one question related to the, let's say, statistical part. In your first outcome, you mentioned that it's like it was like a % change of bone density. So every paper reported not the mean baseline level and the mean after level, but a mean % change.
Yes.
That's awesome.
Yes.
Yes. It never happens in our other fields.
Yeah.
So that's a really good.
So yeah, it was very good news because we could pull it together, and that's why I had to emphasize. I always have to emphasize that it's in percentage change. Why the other markers are within units, and they are always featured there. How? So it's important that we could have data both related to before and after measurement, and then we could compare the two groups, the bisphosphonates group with the control group. So it's quite complex.
Thank you. And my other question is similar to many of the questions out of just sheer curiosity. If the lack of an adequate gravity causes that much problems to the human body, isn't it easier to just spin the ISS really fast until we reach the Earth's gravity?
There are not enough studies to really know what kind of effect it might have again on human body, because it might also have some negative effects. But there are plans by companies who are planning space stations with this technology.
You mentioned in the beginning that you also hold a space degree, so more in like inspiring terms, how can, let's say, new professionals or medical professionals join space research?
There are many opportunities. As I mentioned, one of them is Unispace, where Semmelweis is also involved with 20 other Hungarian universities. There is a special degree for space healthcare professionals. There are great opportunities within the European Space Agency. There is an academy in Belgium where you can apply for specialized courses which take approximately 1 to 2 weeks, and they are financed by the European Space Agencies. There are even PhD funds related to space research. So, and there are more and more companies as well who are conducting research activities and product development related to space medicine. Not to mention that there are even very good opportunities here in Hungary as part of the Hungarian human spaceflight program, which goes on. So even if our astronauts returned, we are just continuing analyzing the results and then making additional development research activities with those invaluable data.